Hello, Math 120, and this is Professor Gonzalez. And I'd like to work the homework problems from 1.4. Before I do the problems on 1.4, what I'd like to do is actually give you some notes about this topic to maybe give you some notation ideas and fill in some blanks before we get started. So these are inequalities, and let's just start with this notation right here. If it says something like x is less than 4, what I'd like you to do is I'd like you to think about that as, you've got 0 here, 4 is on the right-hand side of that. The way I look at this is it's saying, I guess we can use this shading one now, and I need to make it a little bit smaller. But what it's saying is, I'm looking for a value, and all the x values. So I'm looking for all the x values that are less than 4. Values that are less than 4 are to the left on the number line, right? Things that are less than are to the left on the number line. Let me make it a little more specific. Now the thing is, we need to figure out, are we going to include 4, yes or no? But this says shade the x values that are less than 4. And less than 4 does not mean equal 4. So you may have seen this as an open circle in the past. But now we tend to like to use brackets and parentheses. So another way to say the same thing is if we want to say we do not want to include 4, we could use a parenthesis. So a parenthesis means not including that endpoint or non-inclusive. So we can do it like that. So those two notations mean the same thing. And this one right here starts us to see this thing called interval notation. Now, interval notation always puts the small, let me write like this. Always puts the smallest value on the left and the large on the right, just like the number line. So when you look at this open interval and it's going to the left forever, we would say this is going or approaching to negative infinity. Now, infinity is always going to be open because you can't include it. You can't include it. So with interval notation, there we go. Interval notation, we would say this goes, so the same statement as this, right? The same statement as an inequality, you can write it as an interval, saying it goes from negative infinity all the way up to 4, and that is open, non-inclusive. So this is another way of saying the same thing. One is an inequality, one is an interval or interval notation. Okay, the other way to look at this, let's do it right here. What if I said shade the x values that are greater than, let's say, 4, I guess. And on this one, I think I want to say greater than or equal to. So we make our number line. There's 0, there's 4. We start off by saying shade the x values that are bigger, right, greater than. And by the way, with inequalities, this means the same thing. Notice how the inequality is opening up to the x. Whoops, I'm sorry, this is not the same thing. Darn it. There. This is the same, these two statements are the same thing. This one, if I read from left to right, I say x is greater than or equal to 4. And this one, you might have to read it backwards, really, right? Because x is still greater than it's opening up. But this is really not a good idea. Even though it's mathematically correct, really is not a good idea to write it that way. It's a better idea to always put the x on the left when you have inequalities. Okay, so this is saying shade the x values that are greater than 4. Well, greater than 4 is to the right of 4, right? So we just, right on the number line, greater than big things that are bigger to the right, things that are smaller always to the left. So now what we want to know is 4 included? And this is saying shade the x values that are greater than or equal to. So this little line right here means that this now has to be inclusive. And a lot of books in the past, and still do, they'll put a dark dot saying we're including 4 in our solution. And maybe I should make that kind of reddish. We are including it in our solution. But really, a more, a way that you start seeing the further you go in math is to use interval notation. And so instead of having a solid dot to show inclusive, we use something called a bracket. And so that says that so it says x is greater than or equal to 4. Now interval notation, right, the smallest value on that interval is 4. And we have to have this squared bracket showing we're including 4. And it goes to positive infinity, and you never include, you can never close in infinity, so that's always open. Okay, so you have that open, you've got these intervals going in one direction or the other direction. And the other ideas is if you have this compound interval, or a compound inequality rather, where we might say in that notation looks something like this. You have the x in the middle. Actually, let me put this in the very middle, I guess. We'll go over here. Get the x in the middle. Your inequalities will always be facing this, it looks like less than, but I'm going to show you something. And really, to be correct, you're going to have these inequalities facing the same way, and you're going to have the small value on the left and the larger value on the right. So maybe it'll say like -2 and let's say 5. Well, this is a compound inequality. It has 2 inequalities built into one. And so the way this works is you read it from the inside out. So you'd first read this one and so let's go ahead and do this. And you're not going to do it this way each time. I mean, once you see this notation, you basically know that a -2 is the small side, right? It's the smallest endpoint. And you would say, well, 5 is the larger endpoint or side, okay? But let me kind of explain the notation just in a little more detail this time. So whenever we do this, we like to write down the critical or most important points. 0 is, it's a nice reference point, but -2 is certainly an important point, and so is 5. So what's happening here is when we read this from the inside out, we'd read it like this, and we'd say, shade the x values that are, and because it's facing to the x, larger or greater than. So shade the x values that are greater than -2. Well, greater than -2 is to the right. Notice that this is just greater than and not equal to it, so this has to be open, non-inclusive. And then if we go ahead and do that again, but we're going to do it once again from the inside out, and this time we're going to start right here, x, and this one's a little more conventional because it's going, the x is on the left-hand side, but shade the x values, we're reading it this way, shade the x values that are less than 5. Well, here's 5, less than is definitely to the left. And it says less than, doesn't say equal to it, so this has to be open. And so the way that this compound inequality works is it says, I'm looking for the x values that are greater than -2 and less than +5. So really, it has to work for both. So the real solution is where it works for both. Let's go green. It works for both problems, right? So x is greater than -2 and also less than 5 all along this interval. Okay, now we need to figure out the endpoints. Okay, and it's, look at -2 is not inclusive, so we use a parenthesis, not a bracket. And 5 is also not inclusive. It's open, so we use a parenthesis, not a bracket. And so this is the notation as a inequality, and it's tempting just to read it from left to right, but you'll read it slightly wrong if you do that. want to read it from the inside out, x is greater than -2 and x is less than 5. And its equivalent interval notation, now listen to the name, interval notation. This is an interval. So interval notation was really made for something like this, because this sort of messy notation just becomes what? Well, the interval goes from -2 to +5, and it's open on both ends. Okay. Let's see, what else do I want to say? Okay, so this is, let me write interval notation. This is called inequality. And there's one other notation that comes up, and that's called set builder. Set builder notation. Set builder notation is just a fancier way of writing an inequality, really. Set builder notation is the most formal way of doing this, really. And this might be new to people. But when we're trying to list answers, we try to list them out. And whenever we list out answers, we use these braces, and we list out the answers in braces. But as you can see, there are way too many answers here to list out. You know, list all the numbers between greater than -2 and less than 5. There's too many. There's infinitely many, in fact, if they're real numbers. So the way we can still use our braces in set builder notation is you first start by talking about what variable you're using, like what the answers are going to be the set of all x's. So that's how you actually say this. The x right there, you would say the set of all x values. Then we use this line right here. It's not the absolute value. When you see that line right there, you're going to say the words such that, and then you just say the inequality. So set builder notation, the way you'd say that is, you would say the set of all x's such that x is greater than -2 and x is less than 5. Okay, now we can go back to the previous examples and write our set builder notation of this guy, and it's really actually pretty easy. All you have to do is go to that inequality and kind of doctor it up with some notation. There you go, now it's set builder. Same thing here, x is greater than or equal to 4. Well, in set builder notation, we got these braces. That was a sloppy brace. X, the set of all x is such that x is greater than or equal to 4, and close your braces. Okay, so that's notation that may be new. The thing you might want to, let's take a little note here on the side. So, note. So when you see a less than or greater than symbol, greater than symbol, this means open, which in the past you might have used like an open circle, but now with interval notation we're going to use what? Parentheses to show openness. And if you see a less than or equal to or greater than or equal to, that's considered closed. Now open means it does not include that endpoint, and closed means it includes the endpoint. And in the past, maybe in previous math classes, they may have shown equal to by making that endpoint a solid dot. And in interval notation, we use brackets to show inclusive or closed. These symbols you can find on your keyboard. This one with a less than with an equal sign under it, you got to really search for that. But you don't really need to search for these because these symbols are on the keypad in MyLab. So you can just use the extended keypad. It says more or less or whatever, but you can click those buttons. Parentheses I didn't see on the MyLab keyboard, but that is on your regular keyboard. And believe it or not, you probably haven't used brackets much, but that's also on your regular keypad or keyboard, I believe. And so I believe it's below the braces, so it's not shifting, and you get close brackets, and if you shift, you'll get braces, which is used for set builder notation. All right, so that's my little spiel about notation and inequalities. The other thing that I do want to say is when you're solving inequalities, you have to be really careful. It's almost exactly like solving an equation, right? Whatever you do to the left, if you add something to the left, you have to add that same amount on the right. If you multiply a quantity on the left, you must multiply the same quantity on the right. That's all the same. There's one really important difference, and I'm going to try to show that in this simple example. So, if I said, if I was comparing, let's say, a -5, and I was comparing that to, let's say, a 3. Well, if I was going to graph that, there's 0, there's 3, and there's -5. So if I'm thinking, how do I want to show this with color? So there's -5. No, I don't want to do it with that color. Let's see, go back. And there is, let's do blue, and there is 3. So someone said, I want you to tell me, are these two quantities equal? Is one less than the other? Is one greater than the other? Well, if I read from left to right, I would say, which, by the way, to keep things less confusing, you probably should read these inequalities from left to right. It's legal to read them from right to left, and you would have to do that with the compound inequalities I was just showing you. But if it's just two quantities, it's best to probably read it from left to right, because that's how our number line is. Small things on the left, big things on the right, and it just kind of clicks better for students usually. But anyhow, what inequality goes here? They're not equal. -5 is less than 5. It's not equal to it, so I better not put an equal sign under it. But -5 is less than 3. Now, let me show you something. What about the multiplicative property of equality? Whatever I do on the left, multiplying by the left, I must also multiply the same thing on the right. So what if I came along to this inequality and I said, well, you know what? I'm going to multiply this left side by -1. And I'm going to multiply, if I multiply the left by -1, to keep this inequality true, I must multiply the right by -1. What happened when I did that? Well, -1 times -5 becomes +5. And 3 times -1 is -3. Is it still true that 5 is less than -3? And the answer to that is no, it is not correct. So it's a big shocker. I did the same rules I do for equations. Whatever I did on the left, I did on the right, and it's not true anymore. The way that you make an adjustment for this is you actually have to reverse the inequality. Let's take a note on that. Note. Whenever you multiply or divide by a negative number, you must reverse the inequality. And that's a simple thing to forget. And if you forget it, the answer is definitely going to be wrong. You can see, why is this? Well, the explanation would be, when you're multiplying both sides by negative, you're basically saying, I want the opposite. Multiplying by negative is saying the opposite. So what ends up happening is, if you have the opposite of -5 is what? +5. That's where it went. When you multiply it by negative, it turned into a +5. And what's the opposite of +3? -3. Well, it went over here to -3. And by multiplying by negatives, it basically flipped those two quantities from greater than less than. So anyways, it reversed the symbol. So that's something that's very important to do, otherwise it will be wrong. So what am I saying? What I'm saying is when we get to solving inequalities, which comes up about halfway through this problem, this homework set, if you had something like, let's say you had negative 3x is less than 15. Well, you know how to solve this. You have to divide both sides by this quantity because I'm trying to isolate x. So I have to divide by negative 3. And big star, right? Big star, you're dividing by negative. So whenever you multiply or divide by negative, we must reverse the symbol. So I'm going to put a big star there. What happened? Go back to black. Negative 3 divided by negative 3 gives me my 1x, which I wanted to isolate. And 15 divided by negative 3 is negative 5. But we have to reverse this inequality. And now that's the correct answer. Okay, so those are some of the main pieces I always tell my students and try to get them up to speed. Let's do some problems. So let's do some problems. Let's see how many more. Oh, wow, that was dizzy. Makes me dizzy there. Okay, and we're almost there. There we are. Okay, homework set 1.1. Or sorry, 1.4. It says fill in the blank. And now I think this will be a little bit quicker because, you know, we just covered this. It says a blank denotes the interval, the closed interval from A to B. So when you see basically these brackets, it means it's a closed interval, right? If it was an open interval, these would be parentheses. And if it was half open, it would be parenthesis and bracket or bracket and parenthesis, right? But the fact is, this is two brackets, which means it's closed on both sides. So this is closed. Next, it says an interval with these two parentheses. These two parentheses we know is called an open interval. Now they want to know A is called the left endpoint, okay? And then B is called the right endpoint. So if we made this, instead of just calling them, well, we'll keep it as A and B. That means that on the number line, we don't know what the numbers are. They're just A and B. But in this case, because they're open, you know, we're talking about this interval like this, where A and B are not part of the set. It's just their endpoints, right? They're not inclusive. They're not inclusive. Moving right along. Number 3, state whether the following statement is true or false. What is the statement? The inequality x is less than or equal to negative 11 is written as the closed interval negative 11 up to, well, first of all, that looks weird to me because I always know that this is the small number on the left and this is the big number on the right, and negative infinity is going small, small, small forever, right? So that's definitely way smaller than negative 11. So that doesn't make sense. But here, let's do this. Let's take this particular inequality, x is less than or equal to negative 11, and let's just draw that because I think visually seeing it's going to help a lot. Our critical values here, I always like to put in 0 for a reference point. Negative 11 is way down there. This is my son's iPad, and his sister, my other daughter, anyways, just called. Oh man, I'm gonna have to edit. So anyways, x is less than or equal to negative 11. And so when it says x is less than, this says less than, x is less than, that means that means to the left, right? Less than means to the left, so we're going to have to shade to the left. And then the question is it inclusive? Is it closed or not? And because it's equal, it's going to be closed. Bracket. Now, if we're going forever to the left, that's negative infinity, and that is always open. So that tells us that this inequality, written as an interval notation, would just be from negative infinity up into negative 11, and it's closed on the right-hand side. And so when we look at our options here, that means that A says the inequality blank is written like this. Well, that's false. We know it's false, but it's false because the inequality is written like this. And I showed you why it's written like that, right? Okay. All right, let's move on to the next one, number 4. Write the given inequality using interval notation and illustrate the inequality using the real number line. Okay, so now we have this compound inequality. And the nice thing with this notation is that this is going to be your small number, and this is going to be the large number on the right. And interval notation works just like that. So that's kind of nice. You can have 6 is the small number, 9 is the large number. Now we need to know, is it open or closed? Well, when I see an equal sign, I know that means it's closed. When I see an equal sign, I know that means it's closed. And when it's closed, I use these brackets. Whoops, I just erased too much. There we go. Okay, so now we need to take a look and see if we can find this particular graph. And I'm seeing C is matching that, right? There it is right there. That matches up with that. Moving right along, number 5. Once again, compound inequality, which works nice for interval notation, right? So this says, shade the x's that are greater than or equal to negative 3 and less than 0. So there's a number on the left and a number on the right. Because there's an equal sign with that inequality, that means it's inclusive, so it's including that endpoint. And then there's not an equal sign associated with x is less than 0. So this is not inclusive, so it's open. Taking a look at what matches with that, well, I'm looking at negative 3 to 0, closed at negative 3, open at 0. This must be A. Okay, moving right along, number 6. Shade the x value that is greater than or equal to negative 6. Okay, I think when you're doing this, it's helpful to maybe graph it at first. So I'm going to do that. There's 0. Important point is negative 6. This says shade the x values that are greater than. Well, greater than is to the right. So greater than is to the right. Then we need to figure out, is it open or closed? Well, it's equal, so it must be closed. Bracket. So there's our answer. Of course, interval notation is going to be easy once you see this picture. It goes from negative 6 closed up to positive infinity open. That's positive infinity out there. So there it is. Negative 6 closed up to infinity open. And what matches with this? And it's looking like what? C. C is closed at negative 6 and goes forever to positive infinity to the right. Number 7. Express the given interval as an inequality in terms of x and select the graph. All right, I think selecting the graph is the way to go first. In fact, I'm going to go ahead and make the graph. There's 0, there's negative 6, there's a positive, so negative 6, there's positive 8, and we know that with interval notation, it's perfect because it describes an interval, right? That's an interval, a starting and ending. Now we need to know, what do the endpoints look like? Well, parenthesis means it's open. And by the way, we know when we see a parenthesis, we're talking a less than or greater than, not equal signs, okay? I don't know if that's helpful with that there, but anyways, oops. So we can see that these endpoints are open. So that means that our inequalities are going to have to be not have an equal sign under it. So the nice thing about interval notation and the compound inequality is you put the small number on the left, you put the big number on the right. The notation is definitely trickier. If I read from the middle and to the left, I would say x is greater than -6. And if I read from x to the right, x is less than. So x is greater than -6 and x is less than 8. And that picture we graphed right there. Where is it down here? This is number 7. This is looking like -6 to 8 and open. This is B. Okay, let's go to number 8. Express the given interval as an inequality in terms of x and select the graph of the interval. So the inequality, let's make a graph of this. It says the smallest value on this interval is -infinity, so we know it's just going forever to the left. Let's put some important points like 0, and it looks like 8's important. Okay, so it's basically saying it's going forever to the left if -infinity is the smallest value. Remember, the smallest is on the left. And the biggest value on the interval is 8. So the question is it open or closed? Well, parenthesis means it's open. So that's what it looks like. And so I could already find that it's definitely not A because that is closed. And it must be C, right? Because C is, what am I looking at here? Hey, this is number 8. Well, it must be, there's arrow. Yeah, it must be C. Okay, and oops, I didn't make the inequality. This is not an interval, so the way we'd write this inequality, the way I would say it, is I would say the set of all x's, or let me just say it this way, shade the x values that are what compared to 8? That are less than 8. Shade the x values that are less than is to the left of 8. And it's open, so no equal sign under it. Number 9, write the given interval as an inequality involving x and illustrate the interval using the real number line. Okay, use the inequality involving x to express the interval. What is the resulting inequality? So once again, I do think when you're new at this, it's not a bad idea to draw a picture, and I can see what's important on this picture. 0, 2 is definitely important, and it says the smallest value on the interval is -infinity. That means it's going forever to the left. And we can say that's -infinity out there. And so it ends up going all the way, so basically all the way up to its biggest number on the interval, which is 2. And is it going to be open or closed? Well, the square bracket means it's closed. So it looks like that. And if I were to write an inequality, I would say shade the x values that are less than 2, but they also have to be equal to 2. And that includes 2 in the answer. Okay, so there it is. X is less than or equal to 2. And our picture is, right, not C because that is open. It must be B because that is closed, and that is -1, -2. And it's closed because of the squared off bracket, or the bracket rather. Okay, number 10. Solve the linear inequality. Let's see. So we need to get x by itself. So I'm going to rewrite this over here. X minus 3 is less than or equal to 1. We are now solving. So remember, what is important when you solve? You're going to solve it like an equation, but if you multiply or divide by a negative number, you must reverse the inequality. Well, to solve this, I'm going to need to do the opposite of subtracting 3. I'm going to need to add 3 to both sides. Right? And when I do that, that's going to give me x. Whoops, that's going to give me x. Do I reverse it? No, because I didn't multiply or divide by negative. I'm just adding, and that doesn't cause that inequality to reverse. Now let's see, 1 plus 3 is 4. Now they want to express this inequality in set builder notation. Remember, I already talked about that at the beginning of the little lecture I did. And so set builder is easy. All you do is just write the inequality in there. Once again, how do you say this? The set of all x's, and then that little thing means such that x is less than or equal to 4. What is the interval notation? Well, the interval notation would be great if we could find the interval. Let's just go to this graph down here. Shade the x values. Let me just use, I guess, this. Well, let's make our own and then we'll compare, just so it's kind of a little more physical that we're actually physically doing it. 0 is there, positive 4 is there. Okay. Shade the x values that are less than 4. What is less than 4? Left or right? And everybody yells out left. Okay, we do need to make sure we see that it says equal. Whoops, it's erasing. It has an equal sign, so that means it's including 4, so that needs to be closed with a bracket. Okay, and so now it's easy to see what is interval notation. Well, it's open at negative infinity and it's closed at 4. And where's that at? That happens to be letter D, I believe. Yes. There it is. Okay, we're getting there. Number 11, it says solve the linear inequality. Okay, let's do that over here. This is 3x is less than 24. How do you solve it? Well, we divide both sides by 3. Okay, I am dividing, so do I reverse the inequality? And some people say yes, some people say no, and the answer is no, you do not reverse the inequality. We're dividing, but we're dividing by a positive, and dividing by a positive is not a problem in terms of that inequality. 24 divided by 3 gives us 8. So now what we're going to need to do is we need to express that as a set builder notation. Well, you just take your inequality and slap it in there, so that's easy enough. Let's write the interval notation. Well, I wouldn't mind making a graph of this thing, so let's do that. There's 0, there's 8. Shade the, let's go to another color, I don't know why. Shade the x, so shade the x values that are less than 8. Well, less than 8, is that left or right? Well, that's the left. So you shade to the left. And then the big question is it open or closed? Well, it's just less than, not equal to, so it must be open. Okay, and so because it goes forever to the left, it's negative infinity. So we've got open, negative infinity, up to positive 8, and that is open. Okay, that's, oh, and then pick the graph. Oh, I just graphed it there, so what looks like that? What looks like that? There it is right there, B. Number 12. Number 12, I got a little bit of space to work, so I think I'm going to write this down here. This is negative 3, whoops, negative 3. X is less than 15. Solve for x. We're going to divide both sides by negative 3. Divide by negative 3. And 3 divided by negative 3 reduces down to 1x. 15 divided by negative 3 is negative 5. And, whoops, let me say big star, what should you be doing? We're multiplying by a or dividing by a negative rather, so therefore we must reverse. Less than becomes greater than. So write this in set builder. The set of all x is such that, x is greater than negative 5. How about an interval notation? See if we could pick this graph. Shade the x values that are greater than negative 5. I got to go to negative 5. Oh darn! Well, that's going to give away something. So let's just do this. Let's start it from scratch. It's good practice for us to just actually graph it and not just try to eliminate, because that's it's better to learn how to graph them really. There's 0. There's negative 5. So let's do this. Shade the x values that are greater than negative 5. Is greater than left or right? Well, things that are greater than are to the right on the number line. So we must shade all the way to the right. And of course, if you're going forever, that's got to be positive infinity. And is it open or closed? And it's not equal, so it must be open. Okay, so the interval notation is open at -5 and goes up to positive infinity, and that's open. So we've got a complete open interval. And the graph that matches with number 12 looks like A, because it starts at -5 and it's open and it goes forever to the right. Let's take a look at 13. We need to solve this problem on 13. And let's go with, I think we could fit it all right here probably. So this says -5x plus 1 is greater than 11. First step, subtract 1. Recalculate, of course that's 0. We've got -5x is greater than 11 minus 1 is 10. Next step, divide by that coefficient, which is -5. And I'm dividing by negative, so I'm going to put a big green star there. -5 divided by -5 reduces down to x. 10 divided by -5 is -2. And we divide it by negative, so that inequality has to reverse itself. Or we reverse it and reverse itself. We got to do it. So as we write this answer in set builder notation, the set of all x is such that, and then we write the inequality, x is less than -2. And then we try to find the graph, shade all the values, x values that are less than -2. Well, that's less than -2, but it's inclusive, so we need this to be open, so I believe that's going to be C. And the interval notation is going from -2, so we got -infinity open to -2 open. Okay. Something that is kind of interesting also that you can do is notice there's infinitely many solutions, and if you pick a value that's in the shaded region, like if you pick -3, let's say, you pick -3, since it's in our shaded region, if you put -3 in for x, the statement would be true. Okay, so that's something to kind of realize. And if you select something that's not in the region, like how about if you select 0, that should be false, and it is false. So that's something, if you put 0 in for x right there, the answer will be false. So what this graph is, so really we're showing set builder notation tells us all the answers, all the values that are less than -2. Interval notation says my answer goes from -infinity up to -2 and it's all open. And then the graph also shows the same thing. Anything that's shaded, any point that's shaded on the graph, when put back into the inequality, will make the left side greater than the right side, right? Left side will always be greater than the right side. And if you put something that's not shaded in, the left side will not be greater, and so it would be false, okay? All right, let's take a look at 14. And it looks like we got a little more work here on 14, so I think I'm going to put this guy down here. If I can get my pen to work, there we go. Put this down here. So we got 5x plus 13 is less than or equal to 3x plus 31. So really, we want our x values on the left, especially when we're working with this inequality. Technically, you could put it on the right and then switch it at the end, but let's just always put it on the left, just for some consistency, I guess. If you didn't do that and you fixed it at the end, I would have 0 problems with that. But just anyhow, so that becomes 0. 5x minus 3x is 2x plus 13 is less than or equal to 31. Of course, subtract 13 from both sides, and we end up getting, subtracting 13 from both sides, what is that, 18? So that zeroes out. We got 2x is less than or equal to 18. Divide by 2. And x, do we reverse the symbol? No, we're dividing by positive, which is no problem at all. And this gives us x is less than or equal to 9. There's our answer. We go back up here. X is less than or equal to 9. And the proper way to say this is the set of all x's such that x is less than or equal to 9. Interval notation. If we were to graph this real quick and put a 9 there, and we went through our little problem and said, shade all the x's that are less than 9. Well, the values that are less than 9 are to the left. And then we see if it's inclusive or not. And because of that equal sign, for some reason that's not writing, because of that equal sign, this must be inclusive. So 9 is part of the solution. Of course, this is going off to negative infinity, so that the interval notation would be negative infinity, open, up to 9, which is closed. Okay, what actual graph will match with that? And it looks like B is going to be the winner. And then we've got 15. Now, 15, we're going to need to distribute. So, and let me go ahead and write the results right over here. 4 times x gives me 4x. 4 times a negative 3 gives me minus 12. Copy down the less than symbol. 3 times 4 is 3x. And 3 times x is 3x. 3 times 4 is plus 12. Okay, now we want to solve for x, meaning I really want to get all my x's on the same side. So I think if I subtract 3x on the right and subtract 3x on the left, I'm going to get x minus 12 is less than, that zeroes out, 12. Now I'm going to add 12 on both sides, trying to isolate the x, and I get that zeroes out, and x is less than 24. So that is my answer. X is less than 24. Of course, writing this in interval or set builder is the set of all x's such that x is less than 24. And the interval notation, let's see if we can find this interval. Now, big clue, this is less than, so it's not going to have a square bracket. And we're looking for the x values. We're looking for the x values that are less than 24. That must mean it's going to the left. It's going to the left and it's open. That's really looking like B, isn't it? Yeah, B is the right answer. Okay, I got to be consistent, I guess, since I use black the whole time. There we go, number 16. Ooh, look at that fractioning messy thing. So when we have fractions with equations or inequalities, if we'd like to clear the fractions, we just multiply by the LCD. Now, if you multiply by a negative LCD, well, I don't know why you do that. You would have to reverse the inequality, but we're just going to multiply by the LCD. And the LCD here with a 4 and an 8 happens to be 8. So I'm going to multiply the left side by 8, and I'm going to multiply the right side by 8, 8 over 1. So let's figure the result here. So notice when we have, maybe I'll use color. Notice when we have 8, what's 8 divided by 4? Now I got to use a different thing. 8 divided by 4 reduces down, or 8 divided by 4 is just 2. And so we've got, basically we have 2 times 1 times, no, let's just leave it there. Okay, let's just leave that. So we have 2. I'm going to copy down the rest of this problem, which is just in parentheses, x minus 7. So all we did was take care of this first fraction, and then the result of that fraction is going to be distributed, okay? Same thing's going to happen on the right-hand side, where we have 8 over 8 reduces down to 1, leaving us with a 7. So we have 7. And then we write down the rest of this in the parenthesis, which is going to be 2x plus 1. Whoops, parenthesis. Now we need to distribute 2 times x is 2x. 2 times a negative 7 is negative 14. Is greater than or equal to 7 times 2x is positive 14x. And 7 times 1 is 7. Okay, so a lot of times when we're solving for x, we like to subtract the smaller amount out, but we're going to go ahead and put that x on the left because we want our x values on the left with inequalities. Once again, you can fix it in the end if you did it the other way, but I'm just going to be consistent and do it this way. 2x minus 14x is negative 12x. Minus 14 is greater than or equal to 7. Let's add 14 on both sides. And this gives us negative 12x is greater than or equal to, what did I say, add? So that's 21. And then finally, and I'm out of space almost, but finally what you got to do here now is you're going to have to divide by negative 12. And notice I'm using more color. I guess I'm always using color, but I'm going to make a big green star. We're dividing by negative, so we better reverse our inequality. So this is going to give us negative 12 divided by negative 12 is x is now less than or equal to, and 21 over 21, it's going to be a negative value. Let me just make sure we don't lose that negative. Positive divided by negative is negative. Now 21 over 12, right? Do we see some common factors? How about 3 times 7 is 21 and 3 times 4 is 12, so the common 3's will reduce. So x is less than or equal to negative 7/4. Nice. Set of all x is such that x is less than or equal to negative 7/4 is our set builder. You may want to, let's see, space-wise. Oh, good, that's not going to take much space. Let me take a little note with this guy. Actually, I think I can fit it right here. So these are notes here. Whoops, I don't want that. What happened? How do I get rid of that? Go, get out of here. Okay, that's not cool. Not sure how to get rid of that. I'm swiping and moving and it's not going. Get out of there. Go back that? No, that didn't do it. Oh man, you got to be kidding me. So anyhow, let's finish off with the smallest screen in the world now. So now what I wanted to show, well, that button means to share, doesn't it? I don't want to share. Oh no, don't do that. Sorry about this. Okay. Swipe. Still not going to do it. I don't know what the heck I just did, but so anyways, this 7/4, can be written as a mixed number, right? 4 goes into 7 one time with 3/4 left over. So I guess what I'm trying to show you in this problem is negative. When you're graphing the mixed number negative 3/4 is negative 1 3/4 is easier to graph than negative 7/4. So you can see the negative 1 3/4 is like right there, and actually they put them in the right place on all of them. So we got to find the problem that says say the x values that are less than or equal to negative 7 3/4. So less than means it goes to the left, and equals means it's going to be a bracket. So this problem must be D. Okay, and the rest of the answer here is negative infinity, and that was negative 7/4. So this is going from negative infinity up to 7/4, negative 7/4 rather. And once again, when you're inputting these parentheses and are there parentheses on both ways on this one? Parenthesis and then a bracket. This parenthesis and bracket comes from your keyboard. Infinity sign is not, well, you can find it somewhere, but it's also on the MyLab keyboard on your computer screen, so I do use that. Okay, I hate this tiny little screen, but thank God we're down to the last question anyhow. So how do we simplify this? We'll add 3 to both sides, and that's just going to give us y is greater than or equal to 9. If I were to graph that, so shade the y values that are greater than 9, well, That's greater than 9 right there. That's looking good. And then the other piece that we have to remember is it's equal to it, so it must be squared. And a squared inclusive bracket, there it is. So B is my graph. My interval notation, or set builder rather, is the set of all y such that y is greater than or equal to 9. And the solution set expressed as interval notation is just going to be closed at 9 is the smaller value on our interval. You can see it right there, all going all the way up to positive infinity, and that's got to be open. And that is it. Whew, I'm running out of gas here, and the screen is not cooperating. So we are done. I hope this helped, and you have a great day. Goodbye.